Hello and welcome to the Road to Autonomy. The Road to Autonomy is brought to you in part by Stantec Generation AV. Stantec Generation AV combines some of the most experienced AV experts in the industry with the resources of a global engineering firm. Stantec Generation AV provides education, consulting, assessment, and guidance to any industry interested in autonomous vehicles. Learn more at stantec.com. Hello and welcome to the Road to Autonomy. I'm your host, Grayson Brulte. On today's episode, we're absolutely honored to have Peter Virk, Vice President, IV Product and Ecosystem Blackberry. Welcome to the podcast, Peter.
Thank you. Thanks for having us.
I'm very excited to have you here because you're a Rover fan and connected cars are the future, so I can't wait to dive into this conversation. Peter, you have a passion for cars. When you were younger, you spent your summer holidays with your uncle repairing his vehicles. Is that where the passion first began?
If I was to be honest with you, I think the passion must have first began with the toy cars my parents bought me. I think that's where the obsession started. And it's hilarious, even when my kids were growing up, my parents would tell my kids stories where, I would play with these toy cars, have this little garage I would make and drive them around. So yeah, it must have started at an early age where four wheels I just fell in love with. And then from that, I think cars was one thing, but I used to take stuff apart. So even remote control cars and other things like that. My parents were like, surprised and shocked sometimes. They'd be like, we bought him this new thing. Why is he taking it apart? It took me years to realize why I did it. And maybe it's because I was an engineer, a born engineer, right? I just needed to know how things worked. And that hasn't stopped today. I still do it. I have a passion to know how things work so we can improve them. And it could be bikes. So I'm currently into road bikes as well. It could be cars, anything with wheels or anything else. I love a challenge. So that was probably the first bit, toy cars and, my small BMX bikes and so on. But every summer holiday, I would go and visit my grandparents and then obviously my uncle. And he used to work actually at Ford. And he had some of like a Ford XR3i or a Ford Fiesta XR2i, the sort of sporting models, as well as some of the Mark 1. I'll never forget the Mark 1 Ford Escort Mexico he had, where we literally rebuilt the engine in my nan's garden. And as a young teenager, that was fun. It really was fun. We'd get a bit messy with oil, but I actually saw how an engine worked and, what you could do to fix them. So yeah, that's where the journey began. It then kind of led on where he also helped. And he says, it's clear you like cars. I then applied for an apprenticeship, which was back at Rover Group back in 95, where I actually joined the company. So I finished high school and I was very fortunate to go on a program where they literally invest in you for 5 years and, take you to college and university. But where you would get your, college or school holidays, I actually went to work. So it was a balance of working on projects across the whole business from everywhere from the safety lab where they do crash tests to manufacturing, see how things are put together. And then in the later years, I kind of went electronics that's my thing. So I got to visit the whole company and get a taste for what I wanted to do. And obviously then, when I graduated, it was infotainment. And then obviously from infotainment, it's become connected cars and innovation, pushing the boundaries and enjoy that experience. And it's funny, we say 25 years. Over that period, I got to meet so many people, learn from so many great leaders, and obviously had the chance to inspire others too. And, we went from ownership from where BMW owned the organization, Rover Group back in from 95 to 2000. Then the company split up a little bit. Ford took ownership. So worked with the Volvo guys, spent time in Gothenburg. Obviously, in the latter stages, it was then Tata Motors, where we saw the huge growth in the expansion of the cars. Yeah, had the luxury then to kind of build a team, build some world-first technologies and get first to market. And then I think my last project I left I was very fortunate with a small team to be the creative innovators of PV Pro, which is the connected infotainment platform that's in now all the JLR vehicles. Yeah, that was one of my final big fun projects to bring to life.
I have a Range Rover, so I'm running your PV Pro system. I want to tell you, the Wi-Fi in the car works beautifully. When you connect the iPad, there's no hiccups. When I go in there with my iPhone, it automatically connects to the network. Well done. And the best thing is the air conditioning, I live in South Florida, works consistently with no problem. So well done on the engineering front there.
Perfect. Well, team collaboration, right? That's what it takes.
You have this 25 years of experience at the Rover Group. You have this lifelong curiosity of taking things apart You're learning how they work. Putting this together, how are you thinking about the future of mobility?
Wow. That's the interesting piece, right? I like to try and put my feet in the customer's shoes, but also the customer's shoes of tomorrow. And if we think about mobility, we all know where it kind of came from. The question is, where is it going? And I think things have changed. There are some people, potentially you and I, we love driving. So we want to be in cars that we can drive, have fun, wind back, listen to some great music or streamed music from, Spotify or Apple Music and so forth, and be entertained. So that's one aspect that I think that needs to continue. But then there's the next generation where mobility is about getting from point A to point B. And people just want to get there without friction. There's a load of options where a lot of companies have started sharing vehicles and autonomous vehicles. And I think it's about that balance. We're still in the early phases of that, but there are times, and I'm sure you must have done it yourself, where you kind of go, I'm stuck in traffic. Do you know what? It'll be great just to kick back, get me away from the traffic. And if you live like I do in the countryside, when I'm on the open road, then I'll take back in control because I like to enjoy it. So I think that's one element. There is definitely space for mobility, smart mobility, where you can go where you want to be. What am I going to do during that smart mobility in those autonomous cars? Is it productivity? Is it rest? Is it time to rest? Or is it time to catch up? Or I don't know, what's the latest Netflix film that you missed out on? When we get to level 5 autonomy, clearly, not to the levels we got today. That's kind of where it's kind of heading. The future, if we was to really push the boundaries, is it should be, you shouldn't have to think about it. You shouldn't have to plan. My life, my schedule will be planned. It's got to know I've got to get on the Eurostar tomorrow and a vehicle will just turn up for me because maybe I'll be in that subscription. And the type of vehicle I want, is it because I want to lay back and sleep in there? Is it because I want to read something or do some work? Or I want family time. Can you imagine that? You're going on your summer holiday where, you've seen it in some of these futuristic mobility cars, the seats turn around and, you're in a cocoon, in a safe environment. You want to spend time with your family. You want to have those conversations that you would have on the dinner table, but actually have them while you're moving on the road. That'll be fantastic. So I think the future is going to be what we make it to be. We'll go through some iterations, but there's definitely a long journey there to get to that nirvana position. And I think that's the exciting part of it.
Well, there's a long journey. We're going to learn a lot along that way. We're going to see different interesting use cases. You brought up holidays. I look a lot at RevPAR numbers. It's revenue per available room for the hotel lodging industry. And we're seeing this summer, the numbers, they're going up 30, 40% over average what they have historically because the consumers want to spend. So I start looking in similar to you. I love the line, customer shoes of tomorrow. So I'm going to put on the customer shoes tomorrow and I'm going to go 10 years, 15, 20 years into the future. And I think a lot about this. If you're going to land, let's say you go from London Heathrow to Nice, France, and you're going to take a vehicle down to Saint-Tropez. You're going to go with a family for a long week or a weekend. When the minute you land, the vehicle's there to pick you up, says, hi, Peter. Okay, this vehicle's for Peter and his family. And then notifies the hotel in real time, Peter and his family's on the way. They can optimize that room. It's no longer, well, I'm sorry, sir, your room's not ready. Well, my kids have to take a bath. They were very tired from a long trip. You eliminate all that friction and you're spot on that. Once the friction's eliminated, then the commerce starts to flow because then consumers are inclined to spend more money. When they're inclined to spend more money, do you see the BlackBerry Ivy being that platform that's going to enable this future?
Without a doubt. We talked about reducing friction for consumers going forwards. The way that you reduce friction is you make things happen. You make it easy. Today or, yesterday, I would have to plan all of these things myself. I would have to work out them, calculate them. How long is it going to take? What's my ETA? How does that work? And so on and so forth. But actually now we are in the era of connectivity, digital assistance with machine learning and AI. The bit and the role that we've got to play is to bring the car to join that bigger world ecosystem of me and my personalized life, as well as my family life, right? As I choose to opt into certain points. And that's where Ivy comes in. We talk about all of these points in terms of where's the vehicle? What does the vehicle have? What does the vehicle know about me? What is my accurate ETA? Can that be updated? And would it potentially share with the hotel that, this is the time that Peter and his family are going to arrive? So there could be that really nice VIP experience where we get welcomed and it knows us and our preferences. Or there could be that very simplistic approach. There's just a parking space available with our names on it to give you that nice, friendly welcome touch. And then there might be other things where, if you're in that vehicle and you're driving, there could be things where you might want to order your food, your menu, you can have a conversation. It's all of those points. But also remember, we're moving into the era of electrification, right? Electric vehicles. And if you're doing that long drive, you need to plan, where do I need to go? Where do I need to stop? How long do I need to charge for? I don't want to have to work out that. I've got a smart vehicle. It's got a huge compute power. So why can't the vehicle, as well as the wider connectivity systems, calculate all of those things for me and just say, hey, we've dealt with it. We know you need to get here. This is the place that we're going to suggest you stop. While you get a charge, go and have a comfort break, have something to eat, have something to drink. And by the time you've done that, there'll be enough charge for you to carry on your journey. Take all of that mundane planning and all of that friction away from me, because that gives me time back to what I need to do. But that's only going to be possible if we allow the vehicle, which is an IoT device, and connect up the dots. And what IV is basically doing is making that available. Take all of that information from the sensors and the signals of the vehicle, normalize them, then add smart aspects like machine learning, where it knows me and my behavior, my style and preferences, and then make it better over time. And, that's kind of what I call the evergreen vehicle. It just gets better every day you use it, which isn't how cars have been historically. When you buy a car yesterday, it was as it was, you drove it off the parking lot. And then for the next 5-10 years, it would be exactly the same, as long as you've maintained it and kept it going. But the car of tomorrow with IV will adapt. It'll adapt to you. It will know your preferences. It will change. We've got software over the air around us now. So there'll be new features. There'll be ecosystem partners that we can allow to come in and work. And these aren't new innovations. These are expectations from consumers. Why? Well, we've kind of got it in our home life. I've got a Google speaker, or I've got an Echo, Alexa device, and I ask these things, or I've got a smartphone. So why can't that car join that part of my digital life?
It has to. Consumers will demand it.
Exactly.
I was thinking the other day, so I run my house on Siri, and I was thinking the other day, why do I have to ask it to open the garage? It knows I'm pulling into my driveway. It should just know, okay, it's raining. He's going to want to go into the garage. Why do I have to think? And I start thinking about all these mundane things, or sometimes you leave the house and you're late for school, you're in a rush, you forget to close the garage. Well, then it goes through your mind the whole day, and it causes all this stress and friction. Okay, I'm going to go back home now to make sure the garage was shut. We shouldn't have to think about things like that, because it's an easy problem to solve today. Exactly.
There's enough sensors, there's enough connectivity to join those dots. And, you sound very similar to me. You're an early adopter of technology. I've IoT connected my house from the early days, probably drove some of my family insane when we're trying to set up those smart skills and they work at a random time. When they're programmed off your device and then you go away on a business trip and then you're in a different time zone, things get really confusing, right? These are all the learnings that we go through. But I completely agree. If the platform learns what I do, I don't need to be an engineer to program it. It should monitor and see what's happening and then apply it. So to your point, if you leave the house every day and you always close the garage door, you know what? After 2, 3, 4 times, just do it. And if you don't want it, you can always undo it, right?
Yep.
And it's at the phases as people get more comfortable with technology. First is the suggestion of doing it. Second is the notification that I've done it. And then the third piece is I just do it. Don't even worry about it. And that's where cars are going to go. And that's what we're trying to do with Ivy, is basically make those triggers and those sensor points available so people in their own time, safely and securely, can start to build and adapt and be comfortable with these things. So, I see our lifestyles from our home, the office, from pleasure walks or treks on bikes, and our transport mobility to get there all start converging and be that platform that's relevant to me based on my personalization, or maybe even my family. It's about like connecting those dots. And I think it's possible. It's just got a little few steps to make. But hey, we're never complete. We are never complete. There's always something new to do.
And we're getting there. That's the fun thing about tinkering with something. Okay, so then you wanted to lock the doors when you leave. There's all these things that you can add on to it. As I mentioned, so I drive a Range Rover. You were at the JLR for a long time. Is the Ivy platform agnostic where, for instance, you can run on a BMW, you can run on a Ford, you can run on a Honda, so no matter the OEM manufacturer, the Ivy platform can carry across a variety of OEMs?
So that's one of our core foundational principles. For Ivy to be success, it needs to be ubiquitous across the industry. If you think about most cars, a lot of the signals and the sensors are the same. Most cars have 4 doors or they have 5 if it's a hatchback, or 2 doors even. They have seats that can recline, they have air conditioning. These things are common. And actually, each OEM today has built their own vehicle signals and sensors in their own language base. And if you think about Ivy like a universal translator in the first instance, that's our role. Our role is to normalize those signals, make them speak one simple, reliable interface, and then make that interface shared with an ecosystem. Because one of the things that slows down innovation and increases cost is fragmentation, because then one vehicle line versus another vehicle line does something different. You don't get the scalability, but then you struggle to get partners or developers because, hey, there's not that level of or volume or capacity from the vehicle park. So Ivy normalizing that is so fundamental. At the same time, we also need to give our customers choice. So people will have different hardware. There'll be different chips from, Qualcomm to NVIDIA to NXP and to whoever. They will be different cloud vendors too. And we need to adapt and allow that adaptation where it's closely coupled, but loosely linked with other partners to enable our customers, because we also know you can't change everything, right? And it's about necessarily those stepping stone approach, which is give me the value of Ivy, normalizing the data and the machine learning, but the parts around it can change. And that's now becoming available and possible in the car because, if you think about a lot of automotive manufacturers today, they've been building everything inside the car. Then it's kind of moved to the connected car. And it's like, wow, we can push this all to the cloud. Yeah, that's great when you've got connectivity. But then there is a cost of pushing data to the cloud, the cost of, storage and compute, which might not be big for when you've got a smaller sized volume of vehicles, maybe 500,000. But then as the vehicles become 10 million or 20 million or 30 million, because the vehicle part will keep growing, those costs will rise. And what we do with Ivy is we're bringing that processing and that capability back to the vehicle. So if you think about some of those models that you would run in the cloud, well, actually the hardware in the vehicle, because of ECU consolidation, has the ability to run some of that compute back in the car. So not only does it give us that efficiency, but it also allows us to do things which may be akin to what people want in terms of privacy. I don't want this data set or information leaving the vehicle. I don't want this information to be shared. Process it locally and then just give me the trigger to enable X, Y, Z. And I think, we are seeing this in different territories and countries in the world where certain data points or certain data sets will not want to be shared. And that's, again, where Ivy supports the OEM, the territories and the markets to help bring that and blend that and give that, solution that's an industry solution. Because most importantly, anyone can launch a solution. But to make a platform viable and sustainable, you've got to maintain it. And you can only maintain it when you've got scale. So then these are all the foundational pieces that we take into account as we're developing and building Ivy.
You're doing it right as you develop Ivy. As you develop Ivy and you scale to more and more consumers and eventually commercial vehicles, are consumers and commercial vehicle operators, are they demanding connectivity in the vehicle, saying we need over-the-air updates in order for the infotainment to properly function? Are they putting the pressure on the OEMs?
I think there's a mixture. Firstly, I would say, and we'll break this down to, I guess, we'll start with consumers and we'll talk about fleets and commercial vehicles. So firstly, I think there's a consumer expectation that has changed. I get over-the-air updates on my smartphone, on my smart TV, on my smart speakers, and anything else that's smart in the house anymore. So why can't my vehicle, right? And this is about that continual improvement, not only to, I guess, what automotive OEMs are doing to improve the quality and the robustness, but also to start adding new feature, new content. the phone I bought 2 years ago could have been the same device, but because of the operating system improvements, because of the new applications, I can do something new on it. Cars are moving in that same space. So this is why software over the air and those changes are definitely being added, which helps the consumer because that's a consumer expectation. On the fleet and commercial side, the same is true. People are always looking for efficiencies. There's certain regulation pieces that need to be met, especially with, let's talk about electric vehicles and sensors for safer driving. If we can reuse hardware that's already in the car and define a new feature or function through software, and we've all heard the term, the software-defined vehicle, that's the game changer. And that's where it will help fleet companies who potentially can get more longevity out of those vehicles because, if you think about an electrified vehicle, there's less moving parts, therefore they'll last longer. Okay, there's challenges around batteries and so forth. But again, how do you make them relevant when they're 2 years old, 4 years old, and so forth? How do you make them smarter? And I think these are the elements that are key. The other piece for fleets and commercial vehicles is key is how can you link them back to the fleet owner's wider ecosystem? Right? Again, how do I link that into my delivery system so it knows when it's going to deliver, where it's going to go, optimize those routes, optimize those chargings or fill-ups, and so on, where we've seen in the industry a lot of add-on black box ECUs being added to cars to kind of simulate this stuff. Well, the sensors and the capability and the processing capability is in the vehicle. It's the software that now needs to define that. So, yes, definitely on the consumer side, definitely on the fleet and the commercial vehicle side, these are just slightly different nuances on the end use case. But actually, if you strip it all back, it's about getting the data exposed from the sensors in the car in a safe, secure manner so I can do X, Y, and Z. That's what it comes down to.
I want to build upon that because on the March 15th, 2022 episode of the Get In the Connected Vehicles podcast from Blackberry, you stated the following about connected cars. I want an always on, always connected, and always up-to-date experience. Well, now that's possible with electrified vehicles and connectivity. It's now moving to, I just want something to happen seamlessly. I do not want to have to think about it. The car should have intelligence to work that out. It knows my regular journeys because I allowed my permission for the vehicle and the technology behind it to know that. I fully agree with that statement. How do we get here, though?
The first and foremost thing is you get there through collaboration. And this is why platforms like Ivy are there for others to build upon. A single partner provider can't do all of these things, right? So we always have to think about what is the end consumer goal or the commercial vehicle goal? What role and part can we play? Make sure that we drive and deliver that sustainably. And then where is the space for our partners? And when it comes to that, it's a term I've used for many years, the always on, always connected, maybe even always listening, right? That's the world we live in, and always available. These are foundational pieces that we expect because that's what we've got used to in our lives. Our smartphone may look like the screen's off, but it's actually on. It's available. It's listening. It's giving me alerts when I need them. Why wouldn't I not expect the same from my vehicle? And I think that's quite key. So making sure that these hardware elements like the battery and the capability are there, making sure that the platform supports these things, but also protects you because you've also got to know, actually, something isn't infinitely on if it's not being charged. You want to protect yourself from, well, we were always on, but guess what? On the 11th hour, the battery went flat and now you want to go somewhere, you can't, you forgot to charge it. That's not going to work either, right? So it's about designing these platforms with the right enablers in place and then giving the freedom to our OEMs and to our ecosystem partners to build on that innovation. And I think that's where lead times can be shortened, innovation can be increased because, we're providing that foundational bed. And also it's the ability of, historically, having worked in the automotive industry for so long, we always looked for people with automotive experience and X years of this and X years of that. But actually, if we can build a platform that can abstract safely and securely and provide and allow access for others to innovate in software where you don't have to be an automotive engineer or you need automotive experiences because the platform looks after those things. It looks after power management. It looks after the safety, security. It looks after X, Y, Z. So the innovators can come in and even, maybe even my children who are getting into software, they in the future could have the ability to allow applications and services to be made available in the car, because there will be applications that run on top a foundational, safe and secure platform. That's where we're moving to, and that's what the industry really needs. And we see ourselves as part of that jigsaw, a key fundamental part of that jigsaw, where we are here to help others, but most importantly, to enable others as well. And that's the whole life cycle sustainability piece in the digital phase that we want to contribute to.
You mentioned safe and secure many times. Now I'm going to go on the Wayback Machine. I've had more Blackberries that I can count on, and I had individuals I knew that worked in the Secret Service, worked in the White House, and they all ran Blackberries because the security and the encryptions the device offered. And that seemed to me, knowing individuals going way back in the day to old Blackberry, that it was very proud of the encryption and security heritage that Blackberry had. Has that heritage of security and encryption carried over to the Ivy platform?
Totally. It's a foundational piece that's important, and we know it's super important to us. It's super important to our customers, and it's what the platform offers. It's a foundational piece, right? It's not something that is optional. It's expected, right? In everything that we use today. So, that knowledge base and that strength is one of our pillars that is very important to us and our customers, that we will continually build upon and continue to create and innovate on as well. Things don't stand still. So it is super important to us. And, we take pride in having that, all from the secure elements of what BlackBerry offer, the QNX operating system, the fact that it is the relied, trusted on operating system that interfaces electric vehicles, autonomous systems, and so on. That's an element of pride, but it's also an element of continue to adapt and change to the changing world around us for our customers of today, but also tomorrow. And it's making sure we continue to iterate and adapt.
Looking to adapt and putting a security mechanism on top, hundreds of millions of dollars, or in your case, pounds, a year are lost in skimming for fraud at gas stations. It's starting to happen at an electric vehicle charging station. Are you working with developers to build a secure payment mechanism, either for an electric vehicle or for a petrol vehicle that can charge without having to worry about getting your credit card skimmed?
Totally. That's one of the use cases we have started to work upon with a partner and actually demonstrate. So one of the innovative startup companies we have who's joined our platform is called CarIQ. And that's exactly what they do, is they want to reduce the potential, card skimming or fraud elements, but not only just for card skimming, but also then it's looking at the next generation of fraud even beyond that. I'll give you an example. Let's just take a common vehicle of today where I fuel it up with either petrol or diesel or gasoline, whatever we call it in each of the territories, knowing that the vehicle is an authenticated device because it's connected, can drive up to a gas station. It can then know its identity and potentially, based on the profile of the fleet owner, could also authorize the driver because of there may be an occupancy detection piece. So it could be this fleet of vehicles in these garages and these drivers are all authorized to fuel up this vehicle or fleet of vehicles. So, you would have a dashboard to do that. That's one aspect that allows you to then authorize the pump to start dispensing fuel. You can then authorize it. That gives the gas station the security to say, yes, it's an authorized vehicle, it's safe, secure, it's connected. You then dispense fuel. The other element it potentially also helps is the fleet provider, where if you've dispensed 100 liters, the car confirms you've received 100 liters because, hey, cars have all got fuel gauges, right? They know how much they've got. So you on both sides can connect and check saying, yes, 100 liters on the pump was given me, 100 liters in the vehicle has been received, authorize it, make the payment, done. That's one example where we're using the vehicle processing element, not only to tell its location, but authorize the person, but then also authorize the quantity of fuel that you've taken. Now, that could be fuel, and that could be kilowatts of energy tomorrow, right, on an electric vehicle. The context remains the same. And this same use case can be extended to other things where, you've seen some of these high occupancy lanes or these new toll roads. And because of traffic congestion, they've removed the barriers and they automate them because they expect you to use number plate recognition to then pay your fee of today and tomorrow. In some markets, there are problems with number plates being cloned and somebody impersonating your vehicle. And again, Ivy and the CarIQ platform piece can actually prevent that, because it can say, yes, this car was here. This car did do that. It did go in the lane. It even alerted the driver to do it. Or this car didn't, and it will have all the data and the proof to prove it wasn't there. So not only does it help the secure payments, it also helps avoid any potential fraud where other new types of fraud may have happened in the future. And it's, again, staying on these new challenges by using the data interfaces in the car to help enable and expose that. And I could reel off a number of other use cases in the future, such as smart parking and so on and so forth. It can help. It's, again, comes back to that foundational element of surfacing up that vehicle data in the car, processing on the vehicle edge, and then using the triggers to say, yes, authorize that payment.
I'll say hundreds of millions of dollars in the future could be saved from your platform by eliminating fraud. You're eliminating fraud, so you're saving money, which will eventually trickle down to the consumer. You're eliminating friction. There's so many different scenarios. Seeing it now with the boom of concerts, all the rise of fake tickets. Somebody prints out 5 tickets and sells it 5 times, but only one person gets in. I really like what you're doing there. When you look to gather data, increase the overall experience, can you gather battery health data as well?
Yep. Another example I can give you. So again, we know our expertise about using the signals and the sensors of the vehicle. We're working with partners such as Electra, who have actually got machine learning and AI models around battery cell technology, where not only do they know on the charge state and how far the range will be, so you can give you an accurate range of your driving based on your driving style and the type of roads you're on, working with other partners such as here, because of topology data, but also based on how you use the vehicle and charge the vehicle, it can start to predict cell life, cell degradation, because we all know batteries don't last for life. And then this can also allow not only just the end consumer to have a better experience, it can also help the OEM to help condition the batteries to maximize the use of those batteries by, changing patterns, how things are charged. We always know this rapid charge of 80% and then this final 20% is slowed down. Maybe you will only ever charge to 80%. Maybe you would share that load across the vehicle, battery cells, to help reduce some of that life expectancy and some of those challenges by, optimizing how cars are charged. Are they always rapid charged, trickle charged? And again, using lifestyle pieces that you can opt into and connect to. I always may connect the car when I get home. But because it knows I'm not going to leave based on my schedule till 6 a.m. in the morning, it can say, don't do a rapid charge, do a nice slow charge. It'll prolong the life of the battery. That's not only good for the OEM, it's good for the consumer, but most importantly, it's good for the environment. Batteries and these rare earth metals and so on, they all come at a cost, and so does the recyclability. So maximizing the use of some of these technologies has a sustainability point. And again, use that interface to smarten it up, sharpen it up, so we get the best use of it. So customers are happy, OEMs are happy, we're better for the environment at the same time.
It's a win-win all around. And thank you for bringing up the commodities. Unfortunately, you're seeing it in the UK and we're seeing it in America with the lack of refining capacity of what it's doing. And we have the same thing on the lithium, which is, funny enough, it's a specialty chemical, not a raw earth material, that we have to figure all that out. And then when we have the batteries, we really have to figure out successfully recycling the batteries, because as the society shifts towards the 2030, 2050 goals, we have to have some, I call it a circular economy, where the batteries can't be used once and thrown into a landfill. We really have to figure out to recycle that. And then for a consumer, perhaps there's the consumer that buys a vehicle, your platform, we say, okay, your battery has X amount of percentage left, and this is going to determine the value of your vehicle. So it's giving transparency to the consumer as well as helping the environment. On the other side, you could even say, perhaps if you charge from 2 a.m. to 6 a.m., the energy's cheaper. That's another win-win scenario as well.
I think the other one to add to your point is also how vehicle leasing is going to change. So again, another one of our partners that we're innovating with, this is why I love ecosystem so much, is the life of electric vehicle is going to be very different to a gasoline vehicle. Gasoline vehicles have always been based around, a car's designed for 100,000 miles or 150,000 miles in 10 years or so. Well, electric vehicles, it's going to be a little bit different for, because it's going to be based on, how often it's charged, how aggressive it was charged, and so on and so forth. At the same time, it's also going to be based on how you use the vehicle, high loads, short loads, and so forth. And actually, these insights that Ivy can provide may be able to provide a better residual value of that vehicle after you've used that car, because you'll know the approximation life of the battery life capacity, even on some of the mechanical wear. And you probably go, what does he mean by mechanical wear? you can predict the wear out of mechanical sensors, ball joints through sensors, or other mechanical parts through data analysis and machine learning. So again, all of this data becomes very helpful and useful to work out how is the vehicle used, how is its usage been, and then potentially what is the residual value after that lease. And then as we move forwards, even the leases could change based on what functions you use in the vehicle. Do you really want the full autonomy use case, or if you're like driving like me, you know what, I'll have the level 3 or the level 4. So again, it's scalable depending on when you need it. These opportunities, which we've all read up on, in journalists and white papers, only become possible once the data is made available for us to utilize and consume. That's the key thing. I think that's the game-changing piece. And, it's often a piece I sometimes say is a lot of these intelligent points or decisions that are made in the car historically have either been made by the driver because you know the car, you know what you've got to do, or sometimes it's even the passenger. And in my case, sometimes my backseat drivers, which are my kids, where they'll see certain things and obstacles. Well, if you think of a smart car of the future, it's kind of taking in those human inputs that we use, things I see, obstacles, things I hear, traffic incidents or noises or beeps and bongs. The sensors are collecting these, these LiDAR sensors, these ultrasonic sensors. And in effect, they're doing what humans would do, which is what you and I do. We see the blind spot, we see this. But actually, the balance and what we're going to see, the refinement in the future is going to be, provide me this information, not all at once so I get lots of bings and bongs and flashing lights, but provide it to me as a human gives it to me. Tell me what's more important. And then the less important, you can provide it a little bit later. Refine that experience and tell me what's relevant now versus what's not relevant. And I think those are going to be the game-changing pieces where subscriptions and services are going to change, which goes back to our initial conversation around the frictionless piece. What can you do and what can you tell me? And, I kind of see technology, it is like taking that human element, how we drive cars, and replacing that with sensors.
Sensors will change the game. And going back to your early days at JLR, the infotainment, so instead of the red light coming on, having to get the manual out, trying to turn to page 102, 105, trying to figure out how great would it be if it pops up on the screen, belt needs to be replaced. Okay, and you call the dealer, okay, I need to get the belt replaced. That would change the game and eliminate so much stress and friction.
And that's the challenge today. I think most faults or failures, you can't help it. You'll get a flat tire. Sometimes parts do wear early. Just getting a warning and not having the context just really doesn't help. I always remember a scenario once where my mum called me. She was driving to our house and the warning light came on the dashboard. And then she stops and phones me because she's like, I don't know, what do I do? She says, this thing's come on the dashboard. I says, well, what is it? She goes, well, it's amber yellowy color. I was like, okay, so what is it? She goes, I don't know. It's like a U shape with a wiggly thing at the bottom. And I was scratching my head. I was like, what a U shape with it? And I was like, low tire pressure warning. She goes, well, I don't know. It's that. And I says, okay, take a photo. She pulled over. She took a photo of it. She uploaded it. And I went, right, you got low. I says, have a quick check. Are your tires flat? She went, no. Okay, but they might be. Can I suggest you pull over the next service station, check your tire pressures, or you may need to, or I'll come out to you and we'll change your tire. We don't want you to have a blowout. So step one, these sensors help because actually they've pre-warned the driver that there's low tire pressure. So before the blowout, you can react. The problem is the next steps in the jigsaw are missing. What would be great would be, right, is this thing critical? Give me more information about it. Can I navigate the car to the next service station safely so I don't panic you on the road by giving you this warning mechanism? So I think steps like this, even from a low tire pressure warning, I think is key. The second step I think you mentioned, such as certain parts failing or likely to fail. And through machine learning, you can see that maybe the belt was slipping before it snapped. Now, you and I may not have felt that in the vehicle, but the sensors in the car should pick that up. And by picking that up, these are the sensors that can then go back to the OEM. They can proactively order those parts because there's nothing worse than taking your car to the garage and then say, oh, yeah, we need another 3 days to order those parts in, sir. Friction. But if that can proactively happen, life becomes easier. You take the vehicle to them, the part's already there. You can maybe even just wait for it to be replaced. And everybody's happy. And it helps the whole supply chain about connecting all those dots. So again, this is another area where there's an opportunity. Dots can be joined, where there are new models that can create it. But most importantly, give the safety, but also the comfort to the driver and the passengers. Okay, that warning, is it really severe? I don't know. Provide me context. And even there's a short-term piece where if you've integrated Alexa in the vehicle, maybe Alexa could tell you what it is. So you don't have to. My mom doesn't have to phone me up.
You have that, and I'll take it one step further. If you're going to the garage, especially if the car's under warranty and you're not out of pocket, you get a push notification. Hi, Grayson. Hi, Peter. We noticed that you need to get this part replaced. We've ordered it. Please come in Tuesday at 10 a.m. We'll have the part ready. We'll be able to swap it out. It'll be here in an hour and you're done. Wow. No longer having to call and go through the dial to get to a service manager. Now you actually make me want to go get the vehicle fixed instead of prolonging it from having to deal with all the stress.
You got it. And I think it's all those steps. And this is what it comes into, where potentially, maybe even beyond that in the future, if you are to share your calendar, your availability, or where you're going to be, people could come to your house and fix it. That could be the smart garage of the future or your workplace. They could say, hey, we know you've got an opening. Here's a suggestion. They don't need to see your diary, but they might be able to see when you're busy or free. So actually services that work for you in and around you to give you time back. Because ultimately our lives get busier. Our lives get filled up with new things that we want to do. And then some of these basic, simple tasks can be automated through technology. Just like, I guess, how things have automated themselves through us carrying smartphones, right? There's certain things and routines I don't need to think about anymore because my smartphone does it for me. We're seeing that transition happen from that into the vehicle. And we're also seeing the smartphone and the vehicle getting smarter, not only from the infotainment experiences, but also, we mentioned earlier, the safety, security, the unlocking of your car and then relocking of your car. I don't think it stops there. Just how the basic phone got outsmarted by the smartphone. What's the thing that's going to outsmart the smartphone? Because in all fairness, do I want to carry a key? Maybe I do. Do I want to have to carry and rely on a smartphone? Maybe I do. But there's certain advanced people out there where, hey, I might just want a chip inside me, or I might just want biometrics where it just recognizes me. And again, it's about knowing that roadmap of what's coming, making those data sets available, and then providing a platform for us to all innovate.
The platform's clearly Ivy. Are there limitations today of what can be built on Ivy?
Well, I guess the limitations are from the data sets that we make available. It does depend upon the vehicle's architecture, the signals that they have available, and so forth. So as vehicle architectures are moving forwards, we're seeing a lot of ECU or compute consolidation. That helps Ivy because, you can run more processing and you can do a lot of the machine learning on the vehicle. It also helps expose a lot of the sensor sets and the vehicle signals on the car. So I think these are the steps. I wouldn't say it's kind of a black and white limitation. It's basically as things are transitioning from a traditional embedded ECU to more of a software-defined ECU, things become unlocked even further. It allows that decoupling of there was always an ECU tied to that sensor and you couldn't do anything in the middle, where actually there's a sensor, there's an ECU, it's defined from software, and maybe that sensor is just helping you find a parking space. Maybe in the future, it's parking, helping assist to park the car for you. And then maybe it's also while the car's parked, that same sensor is telling you that you may have had a bump or somebody's, nudged your vehicle while you weren't there. And then the cameras in the vehicle capture that. Again, it's maximizing those sensors that are in the vehicle and using software to change those elements that we can think about. And no one has all the ideas at the outset. The ideas can come over time. So the limitations are sometimes what we can think of or what the architecture of the vehicle has in it. But what I can say is that's rapidly changing. The next 5 to 10 years in automotive changes in terms of vehicle architectures are going to be hugely changed. We're going to see more change in the electrical architectures in the next coming years than we've seen over the last 20 or 30 years, which is actually where the software-defined vehicle piece is actually coming from. That's the exciting piece.
It's very exciting. Today, how many vehicles globally are currently running Ivy?
So no vehicles on the road are currently running Ivy, no production vehicles. This innovative platform is in its development stage. We are now working closely with our customer and partners who build ECUs or vehicles around implementing Ivy. And obviously, we've got a number of proof of concepts and developments underway. So it's not in production at the moment. That's something that we're working on with the customers on. That is something that will be coming in the very near future.
Well, I'm looking forward to seeing it. I call it out in the wild. It sounds really exciting. And putting this together, Peter, as you develop Ivy, you ship Ivy, you scale Ivy, what does the future of Ivy look like? Is it a platform that's always going to be growing and changing as society changes?
Totally. You can't do everything at day one. It's going to be a platform that grows, adapts, and morphs based on the industry needs, the consumer needs, and obviously fleet. And if you look at the automotive industry today, there's 3 prime areas that the industry looks at. How can I make the vehicles safer and secure? How do I make the vehicles meet regulation, be it a safety regulation or, electrification? And then where are those innovative pieces that are going to excite my customers, but also provide an opportunity for our ecosystem partners to all make revenue, right? This is why we're all in business. These are the key things. And while we'll have like every product that grows over time, every operating system, even as we look at the QNX operating system, it's going to continue to grow and morph as sensors expand, capabilities expand in the vehicle. And, we will continue to take on those domains in the vehicle to add further levels of depth, refinement, frequency, and capability. And while, vehicles that will ship tomorrow with IV versus vehicle that will ship in 3 years with IV, there are some elements that you will be able to do with pure software. There'll be some elements that a brand new piece of hardware or a sensor will unlock something further. So it's continually going to adapt and develop, make it smarter, more efficient, is one of the key goals. So it is what I call, it's an evergreen platform that will continue to morph. It will morph based on consumer needs, customer needs, and industry needs. And that's our role, to align those things in the roadmap, make them available, and excite everybody, basically.
Sensors are special. It's amazing with really great software, what you can unlock with sensors and the value that you can create for consumers and for OEMs. Peter, I thank you for coming on the Road to Autonomy because you shedded an incredible amount of light on the wonderful work that BlackBerry is doing with the Ivy platform. And as we look to wrap up this insightful conversation, what would you like our listeners to take away with them today?
I guess, mobility and vehicles, it's an exciting space. It's an exciting space, I guess, firstly, for the developers, students of tomorrow. The work is never complete. So that's one thing, remembering back when I was a student, there are some huge things. Take that passion. If you're a software developer or keen interest in automotive, follow your dream. Never let the boundaries get in the way and push. And, platforms like Ivy and other platforms will allow and make things a lot easier. So that's one thing I would say from a developer perspective. From a consumer perspective, I think it's the excitement. Vehicles of the future will become tailored more towards what you want, what you need, and how you need it, become more personalized and relevant to you if you're a car person or even not. Everyone still needs to move around. So I think that's key. And then I guess for the commercial and OEMs, it's those new opportunities to save cost, innovate, get products, allow you to differentiate is quite key. So look, the future's exciting. It's what we make of it. The key thing is, like I said at the beginning, is us collaborating, working together to really push and unlock that potential and put it in our customers' hands. There's nothing better than getting the feedback from customers when they're saying, hey, I love that. Oh, and can we do this? And how about that? And then we take in that feedback and just make it happen and put smiles on people's faces.
Smiles are wonderful. The future is, as Peter says, exciting because the future is bright, the future is autonomous, and the future is BlackBerry Ivy. Peter, thank you so much for coming on the Road to Autonomy today.
Thank you for having us. Really enjoyed the session.
Thank you for listening to the Road to Autonomy podcast. If you've enjoyed listening, please rate, review, and subscribe on your favorite podcast platform. Want to get in touch? Follow us on Twitter @Road to Autonomy or email podcast@brulteco.com. The Road to Autonomy is produced by Brulte & Company. The views and opinions expressed on the Road to Autonomy podcast do not necessarily reflect the views and opinions of Brulte & Company. The content discussed on this podcast is for informational purposes only and should not be taken as legal, tax, investment, or business advice.